All right, welcome back to part 2 of our rates lessons, where we go over M1, the first measurement unit of Math 20-2. And now we're going to dig into what is a rate, comparing and interpreting rates. So to start us off, a quick definition. A rate is a comparison of two amounts that are measured in different units. Right, so take a minute, think for a second on some rates that you maybe have seen in your everyday life, right? Some unit of measurement that's actually two different units and a comparison of those two things. Some examples of that tends to be things like, if you're talking about the fuel efficiency of a car here in Canada, we talk about liters for every 100 kilometers. Right, that's a comparison of a volume measurement and a distance, right? How many liters of gas does it take to drive a certain distance? If you're buying apples at the grocery store, it might weigh it in dollars per kilogram, right? Or maybe if you're in the bulk bins, it might say dollars for every 100 grams. We talk about gas in cents per liter, right? Those big signs outside gas stations. We talk about speed in terms of kilometers per hour. And in the States, they might talk about miles per hour, right? And that P is representing a fraction, right? So it's a comparison of two things, right? Normally written as a ratio, right? Where we are comparing the numerator unit to the denominator unit. A unit rate is a specific type of rate where the numerical value of the denominator is 1. So instead of things we see here like liters for every 100 kilometers, things like this second one, dollars per kilogram, right? That's saying how many dollars does it cost for one single kilogram worth of whatever you're buying, right? Dollars per 100 grams, not a unit rate, but cents for every 1 liter of gas, right? It doesn't tell you how much it's going to cost to fill your whole tank. It tells you how much 1 liter costs, and then you can extrapolate from there. Kilometers per hour, right? How far can you get in one single hour? Miles per hour, right? Also a unit rate. So these 4 examples are unit rates. There's lots of other unit rates, and we can turn anything into a unit rate. So say you go to the grocery store and it costs you $3.50 for 5 apples. Well, that's a comparison, right? It's $3.50 for every 5 apples you buy, right? If you were to buy 10 apples, it would be $7, and so on and so forth. But if I take those values and I divide them, if I do $3.50 divided by 5, it gives me 0.7, right, or 70 cents. And now that's per every 1 apple, right? So now we have a unit rate. So that can be useful because we just said, right, 5 apples is $3.50. It's pretty easy to then find out that 10 apples is $7, right? But what if you wanted to buy 8 apples? What if you wanted to buy 3 apples? It's hard to estimate the price, but when we have a unit rate, when we know the price per apple, it makes it pretty easy. We can just multiply by the number of apples, or looking at our other examples, right, the number of liters of gas you need, right, the number of hours your trip is going to take. We can multiply by that value, and that's going to tell us for that specific amount. So unit rates are especially helpful, and we can turn anything into a unit rate. So let's look at some examples with rates. Rates are especially useful for comparing two different things, right? If you want to know what's a better deal, right, or what costs more, or what's going to take longer or be quicker, when we compare them as rates, right, we can see that pretty quickly how these things relate. In this case, Natasha can buy a 12-kilogram turkey from one store for $43. A second store has turkeys as well, advertised for $1.49 per pound. Then they tell us that there's about 2.2 pounds for every kilogram. So that's our conversion factor. And they're asking us which store has the lower price. So right off the bat, it can be a bit hard to tell, right, which is cheaper because these two things are measured in different units, right? We're talking about kilograms versus pounds. One of them is a unit rate, right, for every 1 pound. The other one is telling us the price for 12 pounds. So to be able to compare these things, we want the same unit rate, same unit rates to compare. Right, that can give us a better idea. If I talk about both of these things in dollars per pound, I can then see which one has the lower numerical value, so therefore which one's cheaper. So let's look at what we have for the first store. It's 12 kilograms for a cost of $43. Because we're talking about dollars per pound for the other one, I'm going to put dollars on top. I'm going to call this $43 per 12 kilograms. Right? It's still a rate. It's still a comparison of dollars to kilograms, but it's not a unit rate. Let's deal with those units first. Right now I have kilograms. I need to get pounds. So let's use some of those unit conversions we had from before. Right? I'm in kilograms. I want pounds. They tell us our conversion factor. Right? They tell us right here that there's 2.2 pounds for every 1 kilogram. I want to set that up. Remember, if I'm doing unit analysis, I want kilograms to show up on the top so that these two units cancel each other out top and bottom. And then I'm left with, based on the other half of my conversion factor, right, how 1 kilogram is related to pounds, I'm ending up with pounds on the bottom. So as we can see already, this is going to get me to dollars per pound. I'm going to multiply across, right? I'm going to do 43 times 1, so that's still 43. 12 times 2.2, that's going to get me 26.4, but now I'm in pounds. And then to turn this into a unit rate, I'm just going to divide those numbers, right? I'm going to do 43 divided by 26.4. And it ends up giving me $1.63. And now this is per pound, per 1 pound. So now we can compare, right? Now I can directly say, well, compared to $1.49 per pound at the other store, I can clearly see at this point that the second store is a better deal. Right? That's not quite as apparent when we're starting in different units and one not being a unit rate. So let's look at another example. A car travels at 80 kilometers an hour. What other rates expressed using different units could be used to describe the speed of the car? What would be some advantages of these other rates? Right, so 80 kilometers an hour. This is what we use for the most part for our road signs, right, for our speed limits on highways. Because it's comparing two units that are pretty reasonable for a vehicle, right? Kilometers is a pretty big unit of measurement, but cars travel a pretty far distance, right? An hour is also a pretty big measurement for time, but at the same time, you're usually driving for at least some portion of an hour. So some other rates, right? Maybe let's talk about it in, like we mentioned earlier, miles per hour. Right, so kilometers per hour is what we use here in Canada. Miles per hour, that's going to be what they use to measure speed for car travel in the States. Right, they're using the imperial system. Miles are a longer distance, so you're actually going to be recording in less miles per hour. Right, because you're going further for each mile, you can cover less of those miles within an hour. Another unit of measurement we use sometimes, not necessarily as much for vehicles, but meters per second. So what we're doing here is we're taking our distance measurement and making it a much smaller, much more precise unit, right? A meter is a lot smaller than a kilometer. And seconds, right? A second is much quicker than an hour. That allows us to talk about really quick, really fast movement, much more precise. Right? If I was to talk about a very small measurement, right? If I was to shoot a projectile that only went across a classroom, right? Kilometers isn't going to be my best unit to use because I don't even cover even like 1/10 of a kilometer inside my classroom. So I'm going to end up with really, really small decimals. And if it goes really quick, right? If it takes like 3 seconds, that's like the tiniest fraction of an hour. And so if we can be more precise with our units, the smaller units we use, the more precise we can be. And so meters per second is usually used for fast or short distances. Right? You don't want to measure your trip to Edmonton in meters per second, because if you're going 300 kilometers, you're going 300,000 meters. Right? And if it takes you 3 hours, that's going to be a whole lot of seconds. Right? So we want to use more precise measurements for smaller trips or events, larger measurements for larger trips and events. Right? But all of these are talking about the same thing. They're all still just a comparison of a distance related to a time. Let's look at one more example. When making a decision about buying a vehicle, fuel efficiency is often an important factor. The gas tank on Frank's new car has a capacity of 55 liters. The owner's manual claims that the fuel efficiency of Frank's car is 7.6 liters for every 100 kilometers on the highway. Before his first big trip, he sets up his trip meter to 0 kilometers so he can keep track of the total distance he drove, and he started with a full tank. He keeps track of how much he's driven for each chunk and how much gas he bought to refill the amount he used. So we have 2 trips here. Trip number 1. He went 645 kilometers and used 48 liters of gas to travel that distance. Right, so if our base unit, our comparison is in 7.6 liters per kilometer, I want to set this up in the same way. I'm going to put my liters on top and my kilometers on the bottom. Right, again, it's hard to compare when I'm comparing something that's a unit rate to something that's not. So let's turn this into a unit rate. Oh, sorry, this was per 100 kilometers. So I'm going to start by turning this just into a unit rate for every 1 kilometer. So 48 divided by 645 gives me 0.074 liters for every 1 kilometer. Now, if I want to make this look like the units we started with, right, where he has his measurement in liters per 100 kilometers, and most standard Canadian fuel economy measures in liters for every 100 kilometers, is I'm going to multiply this whole rate by 100, right? Which means I'm going to multiply the numerator, by 100 over 100, right? So I'm not actually making any of the values bigger. I'm just changing the size of each of those units. Because that's going to give me on the bottom 100 kilometers, right? I had 1 times 100, but I also need to make the numerator 100 times bigger. That's going to give me 7.4 liters on top. So now we have a better idea, a better comparison. We can see that he was actually more fuel efficient than the owner's manual claims on this first leg of the trip. So let's look at the second leg. What happens then? Well, he filled up with less gas this time, 32.1 liters. But he also didn't go quite as far, 392 kilometers. I'm going to turn that into a unit rate first. Again, 32.1 divided by 392. Turns out that 0.082 liters were used up for every single kilometer driven. Again, the same thing. I'm going to multiply this whole thing top and bottom by 100, right? Essentially, as you see here, I'm multiplying by a fraction that just reduces down to 1. That means I'm not changing the number. I'm just changing what it looks like. And we've used that trick a couple of times now. So that's going to give me 100 kilometers on the bottom, right? Because it was a value of 1. It was a unit rate before. And that means the top is also going to get 100 times bigger, 8.2 liters. So it looks like he was a little less fuel efficient this time, right? Maybe it was really windy. Maybe the road was really bumpy. But we can see here, right, getting those to look the same, right? Same type of rate, same denominator, can help us compare these things visually a lot better. So there's some examples for you to try here I'll put up the answers, but again, always take a look at the practice questions video if you want to go into more depth with these ideas. After these examples, we'll go into our third lesson. Let me take a minute, pause, give these a try. See if you get the answers. If not, check those solutions on the practice video. All right, so this first example we're looking at, we see that the comparison of $2.86 US per gallon that it costs across the border is going to be cheaper in comparison to the conversion in the Canadian town, where it ends up being the equivalent of $3.21 US per gallon. So it'd be more cost efficient to cross the border. In the second example, Paula, if she's feeding each person 2.5 squares, we need about 18.75, which we want to round up, right? You don't want to short anyone. They're desserts. That could be a dangerous game. So I'd recommend buying 19 boxes to be able to feed the whole office. And the last one, Amelia and Bruce taking a walk. Bruce will have to walk for about 5.5 hours in comparison to Amelia walking for 3 hours, so that they burn the same amount of calories. Right? That's going to be based off of their calorie per hour rate. So give those a try if you haven't already. Check the additional video if you want to see more thorough solutions. And keep an eye out for our next unit, part 3, where we're going to start to represent rates graphically. And that's going to finish off our M1 unit.